Hey everyone, let's start this video with another example. A florist is making 5 identical table flower arrangements for a party. She plans to spend $770 on 3 types of flowers: sunflowers, roses, and jabbers. In each arrangement, 30 flowers are to be used with at least 1 flower of each type. Given that the sunflowers cost $4 each, roses $6 each, and jabbers cost $3 each, find the maximum number of jabbers used in each flower arrangement. So this is a system of equations question, right? Because you have 3 items and you have to find the number of jabbers. So let's make our equations. The first clue is that she wants to spend $770, and we know that each sunflower costs $4, 1 rose costs $6, and jabbers cost $3. We then have the equation 4s plus 6r plus 3g equals to 770, right? So that's one equation. How about another one? Is there another clue? She's going to make 5 table flower arrangement, and in each arrangement there's 30. So very simple. There's a total of 150 flowers, right? Since S represents number of sunflowers, R number of roses, G number of jabbers, we have S plus R plus G giving us 150. Alright. So do we have a third equation? Answer is no, right? We've already used every possible clue here. However, it's still solvable, right? If you use a GC, it's still solvable. You just get a parameter in our solution, all right? So using the GC, right, we'll get S equals to 65 minus 3 over 2t. R equals to 85 plus half t. And then we have G equals to t. Okay, now, the problem is they want to find the maximum number of jabbers, right? And because we have a parametric solution, we will be manipulating the t, right? Or they'll be experimenting with the value of t. Now, if you think about it, what's one condition that you have to fulfill? The number of flowers have to be a whole number, right? You cannot, have half a rose, right? Although that's what I buy myself for Valentine's Day to remind me that I'm single. You can't really do anything, right? You can't really have any other number other than a whole number. And you must be a positive number, right? Because you have to use a positive number of flowers to actually put inside the arrangement, right? I think that's quite logical. So that's one condition. Another condition, right, is actually quite specific to this question, is that the number of flowers of each type has to be a multiple of 5, right? Because you're making 5 identical table flower arrangements, the number of flowers of each type has to be a multiple of 5, right? So that's 2 conditions. So if you want to write these down, it's possible. So each flower, or each type has to be of the form of 5k, and each type has to be a whole number, right? Now, if you look at our solutions, we have 3 over 2t, we have half t. To get rid of the fraction, we know that t has to be of the form of 2m, right? So we kind of have a clue, right? So what we want to do now is find the multiple of 5 and 2, which is 10. So we know that t has to be some sort of 10, right? Because each type has to be 5k, and t is even number, it has to be of multiple of 10. But you don't have to really deduce that, right? Then the third condition, basically, S, R, G must be bigger than 0, must be positive, right? Actually, technically bigger than 5, but we've already assumed that. Okay, so we now just experiment, right? If you look at our sunflowers, we have 65 minus 3 over 2t, it'll be bigger than 0. Then we have 65 is bigger than 3 over 2t, t is less than 30, right? So actually, wait, not really, it's 130 divided by 3, sorry, t is less than 130 divided by 3, t is less than or equals to 43, right? Because we are going to look at whole numbers, t is a whole number, therefore we don't need the additional 1 over 3, alright? Now, we look at roses, we have 85 plus half t, so it doesn't really matter, right? Because plus a positive number, you will get a positive number at the end. So we know that t has to be less than 43. So, and we know that t has to be a multiple of 2 and a multiple of 5. Let's try putting t equals to 40. All right. So if t equals to 40, s equals to 65 minus 60 will give us 5. R equals to 85 plus half of 40, which would give us 105. Since all numbers are multiples of 5, we then have the final answer. Therefore, a total of 40 gebras is used. However, what does the question want us to find? Each flower arrangement. Therefore, we have 40 divided by 5 to give us 8 gebras in each flower arrangement. So this is a type of experimentation you need to do, right? Firstly, fulfill the condition, right? You should kind of start off with this condition first. With this condition, you then get this condition. Usually these two conditions will be generic across every type of application question where you need a whole number solution. However, because of this nature of this question, you need each answer to be a multiple of 5, right? So that's the third condition you need to do. Otherwise, if let's say we don't need this first condition, let's say the florist is only making one table flower arrangement of 150 flowers, then the answer would be 42, right? Because if you have t equals 43, it wouldn't add up, right? Because you have like half a sunflower or half a rose. You need to be a whole number, all right? So if there is no 5 identical flower arrangement, if you just one arrangement, the answer will be 42, right? So there we have it, the application questions of simultaneous equation, systems of equations, where we have to take note of the context of the question and act accordingly or experiment with it.